Thank you for coming to my morning session here for Code on the Beach. Before I get to the topic, thank you to all the sponsors and organizers who made this possible, and for you for showing up here. Visit the sponsors in the break. I'm sure they would appreciate it. We will talk today about vision in Microsoft Azure Cognitive Services and Applied AI. Will be a mixture of explanation what it is, a little bit of samples what you can do with it. Some is live code and some is also only talking through what it does based on the public website which has example calls to it. It's quite some services, so that's why we're staying also a little bit on the surface and cannot go very deep. So my name is Andreas Erben. I have been in the industry for the slide is a few years old now, probably it's closer to 28 years now, and worked with fun technologies like virtual reality already in the 1990s. After that, there was no money in virtual reality. I did a lot of enterprise type of work and architecture, integration, but in around 2014, I started again dabbling with more fun stuff, working with Kinect for Windows, which came initially from the Xbox. Then from there it branched out into mixed reality and HoloLens and integrated Internet of Things and RFID projects, which I already actually did in 2008, and applied artificial intelligence. The big theme being to tell interesting stories to customers and not just talk to the CIO people, but to the people who want to solve actual problems. I speak quite at some conference, and that's why Microsoft gave me the MVP and regional director titles. That doesn't mean anything in terms of I'm smarter or something. It just means I do a lot of public speaking. Okay. So what are we talking about today? The talk is about what is there and not why are we doing it mostly, and an overview of cognitive services versus applied AI services. And then a quick description of the most important services with some samples, right? And then a recap. I hope we have enough time. When the last time did that, I had 75 minutes. So first of all, at a high level, all of those services are cloud APIs, meaning they have a few concepts that for a developer are all the same. They have RESTful interfaces, and there may be special exceptions sometimes where service has MQTT or another custom interface implemented, and there's API wrappers available for most languages. So you don't need to assemble your REST calls typically manually, but can just use Python or C#, drop your API in and just have a rich object, rich intelligence experience in Visual Studio and so on. The pattern is always the same. Unfortunately, nothing is free, so you have to set up your resources in the cloud, and typically some might be available in the free tier, but often you have to provide your credit card at one point and associate that with your cloud account. Then you get access credentials and have some tokens that are associated with those access credentials, and you use those in your applications, and then you pay per use. Yeah, that's very, very high level, right? So what are cognitive services and what is applied AI? So cognitive services initially came from Microsoft recognizing, hey, we have Microsoft Research and they're doing incredible things, but we just cannot expose our intellectual property to people directly and give them the bits, the binaries. So let's bundle it in as services and sell those services, like for object detection or to do any type of smart things, right? The goal is to have those easily integratable into apps and provide basically AI capabilities for people who usually do not do AI. Yeah? Then applied AI, actually I had to change my slides, one little bit over a year ago, because suddenly they came out with this term. Before everything was cognitive services, but then they found, hey, we started building services that use other cognitive services. Let's call them applied AI services. And they implement some more higher level business logic on it. For example, they may use different cognitive services to provide a richer experience. There will be two examples about that. My cough, even though I had COVID 4 weeks ago, is I have a little bit of allergic asthma, just to be sure. So, cognitive services, again at a high level, can be grouped in 4 categories, and they may have introduced new services meanwhile. I do not update this every month, this slide, but in general, you have categories, and you have 4 categories. You have decision-based, language-based, speech-based, and vision-based APIs or services. Decision support could be detecting anomalies, like you provide data series, and then, oh, there's a new data that's different. Content moderation, like is there anything naughty happening in things that people upload. Personalizer is funny branded. It's actually reinforcement learning, but it's called personalizer because the most common use case is to give a personalized shopping experience based on what people buy in your own web shop. And then you have language services, which are summarized as language understanding service. That's, it sounds very fancy. This is not like the new stuff like GPT-3 type of we really understand what language is, but more you provide like some language, like some constructs, some keywords, and some little bit of grammar, and then it helps you to make decide what the user intent may have been and map that to actions in your applications. Yeah, so it's basically you can do like Alexa Lite with something like that, right? A Q&A maker would parse a document, like a large document that already has basically titles and paragraphs, and be able to extract questions and answers from that. Text analytics is just a general purpose service to analyze text, and translator, it's in the name, translating from one language to another. So speech has a little bit of overlap. There's speech translation, which is associated with translator, but it works on the actual audio. And then you have speech to text and text to speech. Text to speech is now as advanced that you can actually train. You need to recognize, you need to apply for it. A custom voice, you can actually make Azure speak in your voice, so it can sound pretty creepy. I'm still hoping to help a friend of mine who lost his voice quite some years ago, but I'm still waiting, going through some hoops with Microsoft to see if we can reconstruct his voice somewhere. And services like speaker recognition, which will be used in one of the other samples I have later on, but from the video aspect. That means you have a lot of speakers in an audio stream, and you want to say, distinguish who said, who spoke in what segment. And then finally vision, which is currently computer vision, custom vision, and face API, and we will talk about all of those. Applied AI services, again, the last time I checked, there were 6. Bot service, metrics advisor, cognitive search, and immersive reader. I will not talk to them about them in detail. So we will briefly look at Azure Form Recognizer. That means you provide samples of forms, like your rental application form. If you're a company and you with example data filled out, and it gives them 3 or 5 samples, and then it will be able to extract the bounding boxes of the text fields that change between those forms, and then make it easier for people to then analyze like a form that has been filled out. There's also some forms that are supported out of the box, like receipts and so on. And then Azure Video Indexer, which was previously known as Video Analyzer for Media, and previously known Video Indexer. So they renamed it twice because they had a bigger video analyzer product that they discontinued. Yeah. So again, this is an overview about the service we will discuss today. Briefly also spatial analysis, what that is I have it more on a slide and not a live demo. So the services, right? There was a slide from a different conference that snuck in. Sorry, my slide master got a little bit messed up. Computer vision roughly is, think about this, like you have an API you send an image to, and then you can tell that service, hey, I'm interested in a few things. You can extract text from images, like optical character recognition. You can have some image understanding, like detecting objects, assigning tags, what the image is about. Detecting faces, like not recognizing, but like here's a face, there's a face, something like that. And then get some metadata out of it. What are the colors used, and is it maybe adult themed or image, or has it racy content? And then you can get basically information about those images. Yeah. Spatial analysis, I think it's the left preview meanwhile, but is a bigger. It's based on basically hooking up a camera to a container that runs some logic, and it will have capabilities like detecting people, being able to calculate the distance of the people. And during the pandemic, what they implemented, for example, was like is somebody wearing a mask? That's what people asked for, like in some shops. They wanted to be able to find, like, are people wearing masks? And if not, do they get too close to each other? If they get too close to each other, then do something, for example, right? And you could determine region of interest. Let's say you want to say, hey, if somebody goes here in this area, and maybe they interact with those things that are being sold there, so a shop can get an idea about the traffic in the store, basically. Yeah? It runs on the edge in a container, so that means you don't push all the data to Azure, but you need a little bit of a beefier box with some better graphics cards that does the actual inferencing there. Yeah? So computer vision, let's start with this. So I have the link in here. This is just the Azure information page about it. What you can do, for example, this is an example image with an example call and an example result, right? So you see there some bounding boxes recognized, like this is a person, this is a person, and this is a subway train, even though they're pretty blurry here on this side, right? And this is an interpretation basically on the things on the right side. You see, this is a type of data format that will come back. It's basically, it's JSON, saying like here is a rectangle, and the rectangle has an object. The object is a person, and I have a confidence of 0.764 about that, yeah? And then there's another rectangle. Here's the other part, the subway train. Let me zoom in a little bit. What you see here, and why that's interesting, that you see they actually have an object hierarchy defined here, right? So it's a subway train, but also, so the subway train here has a confidence of 0.80% roughly, but it's also, in general, it's a train. So then for the train, we have a higher confidence, hopefully, and it's in general, it's a land vehicle, so, and also a vehicle. So the confidence between those increases, basically. Yeah? So basically, you can get some information about the type of things you're seeing there. Then you have what I mentioned as assigned tags. You have, for example, here the tags as a train in the image, and I'm pretty certain about that. And then there's a platform as a description, and it's the scenarios indoors, and people wearing clothing, and so on, right? And here it's more like the pure verbal description: platform, station, pulling, building, pulling, like train pulling in. Yeah. Luggage. I don't know where's luggage, but so basically an assortment of description tags that are analyzed, and they're then combined. Also, people waiting at a train station. So typically, you can get a relatively meaningful description of what's going on. Yeah. There's also an example app with Seeing AI, I think. I'm not sure if it's on Android, but on iOS, where they use this behind the scene to help blind people to navigate and detect things, read menus, and so on. Yeah. Actually was developed together with a blind developer of Microsoft, so it should meet the needs of some people. It's free. So metadata, as I said, it's not black and white. It doesn't have adult content. And it's not gory, so it's not racy. It's interesting. I'm not sure what's the difference between adult content and racy, but yeah, okay. I think adult is probably one level more, and with a euphemism. And and it also tells you the dominant black background color and the dominant foreground colors is like all shades of gray and a little bit of dark colors, and there's an accent color, right? Another example, and I will not get too detailed in all of the examples. Oops, that's interesting. All right, huh. Okay, I haven't had that happening before. I mean, this is Microsoft's website. There's not much I can fix there. Yet. Let's see if it stays like that. Huh. Okay. Well, one more try. I can try a different browser. You know, that's what we always do. Because by default, Edge opens up. I mean, it shouldn't be different because, to be honest, but nope. Let's see, one more thing I can try if I sign into Azure. Make sure I'm signed into my account. I mean, it shouldn't matter, but you never know. Okay. Oops. Ended up on a different page. Here. Nope. Okay. So I have a code sample. So let's actually where I can debug into it. So we can explore it this way, I guess. And at least when I tried it just before this talk, it worked. Let me put it this way. So why don't we start with where you have the breakpoint? This is an object character recognition. So when you call in, I hope the breakpoints didn't get removed. Okay. All right. So here you see just the whole flow, right? This is a C# sample. What you do is you basically initialize the client, give it your credentials, and the credentials you get from Azure, and you put them in a local variable. I'm not going to show you my key right now. And you configure an endpoint, and then you provided the location or the data you want to analyze, and then the makes this call to OCR from the OCR call, which in this case, what you notice here, they have in the client that we passed in, they have a dedicated API call for recognized printed text async. There's also more generic call where you say, just show me everything you know about this image. And now let's push that through. And at the same time, try to open. So we're looking at this image, right? So the nutrition facts. And I hope meanwhile it analyzed it. Yeah, okay. So we got back the analysis results, and we can just open briefly. It's a little bit small here. But basically it tells you that it has, it's a language, has the text orientation is up, it has regions defined, and those regions are, there's a bounding box, and in the bounding box there's lines, and the lines have another bounding box, in the bounding box is words, and then the word, let's say the first word is fat. Okay? So it gives you like all the little characters, all the little words on that image, and then you as a developer would need to make something meaningful out of this. So it doesn't give you the full text, but it recognizes just the text on the image, right? But there's an example code how you can output this whole thing. So this would be the whole thing, like bounding box nutrition facts, amounts per serving, of 40 gram, and so on. If I look back at the image, you see there's, for example, this is cut off here, so you would be probably seeing either oris or loris from fat somewhere. Let's see if we can find it. Oris from fat, yeah, see? So it doesn't try to autocomplete or make sense what you're saying, it just gives you the text. All right, so computer vision. Let's, this is the most generic one. Let's say analyze images is the most generic one. Okay, so making first make a breakpoint here. So again, the setup is the same. We're setting up the client with the credentials, and then we want to recognize. Oops, what did I do wrong? So I set it. Oh, I didn't set it as startup product. That's the things you do on stage. Okay, so what you see here is we provided with a list of things we're interested in. Like if you remember on the slide, you could ask it for, hey, find faces, give me a description, assign categories to it. What is the type of the image, the tags? Is it adult or not? What are the colors? Can you detect any brands used in the image, like any famous fashion or whatever brands? And give me the objects that you find. Why that matters? Because you pay for this. So the more you select, the more expensive the call will be because it uses more cloud resources in the back end. So if you're only interested in, let's say, categorizing it as a naughty image or not, then do not select the other ones. And of course, I should have, so we're looking now at, so at this sample here, Colosseum. And the analysis is, like so it didn't detect any group. So again, it gives you an object structure, not just a JSON background, so you can just query it with results.adult score and so on. And it doesn't detect any brands. It found a few tags. There's a building tag associated with it. It's a landmark. And we think that it's actually the Colosseum, so it knows some of the landmarks already. It so for the categories. Then we have the color scheme. It's mostly white and gray. Description. Let's say the caption it assigned is a castle on top of Colosseum. Okay, it's not super precise, but it tries to generate some text that makes sense. In the description, you would find then in the other assigned tags here, building outdoor, front sitting, large, old table. I mean, it's a little bit of a mix of things. Typically, the ones on the top are the more relevant. It's building outdoors, right? Faces, there are no faces in that image. Metadata is again the JPEG with the resolution. And object, it didn't detect any objects in that image. Okay. And here's the tags that is assigned is similar to the categories. There's a sky has been found and so on. Okay, so just to give you a rough idea about this. Let's do the object detection example. So object detection is actually people in this case. So the detection is we have 5 objects, and the objects are person, person, and person. So that's person and person and person. So that's basically what it does. Okay, so if you have time at the end, I can also show it in a different context again, but let's move on to the next service. So custom vision is image classification and object detection basically as a service. You don't need to hire your own deep learning experts and data scientists to train models based on things you're interested in. And what makes it unique is that it works with a smaller set of examples. So with 15 example images of each type, you already get pretty good results. So for example, like detecting a phone versus a mouse or something like that. Or, yeah. So behind the scenes, it uses transfer learning, which means there is a bigger model that Microsoft uses that has been pre-trained to have good knowledge about all the world. And then they basically remove one or top layers at the end, at the top, and replace it with what you train it for. That allows them to work with a lower number of examples, because behind the scenes that models already understands a lot of generic concepts like what is an edge, what is round, what is a pattern, and so on, which could be artifacts that a model internally has. But each model is unpredictable when you actually train it from the bottom up. So, but they did a lot of research into the base model that makes sense. It's optimized for different scenarios. So and I will show you, explain that to you in the portal of Custom Vision. And there's an option to export those models. So you can run those models in the cloud and just send calls to it, or you can also download some of the models and run them on your phone, or on an edge computer, or on your PC in an app, right? So let's, I think I should have had it open here. Custom Vision, so when you log in, you provide your login information, and then what you get is an overview about the projects that you set up. Let's just set up a project for the giggles at a moment. And you need to choose the so-called resource groups. You use it for, let's say, yeah, let's use this one here. No, let's create a new one. Demo code, subscription. So you give it basically the, where is it? Just anything. So you give it all the things that you have set up before in your Azure portal, and it actually pulls those information, that resource groups from Azure. So you need to have some pre-configuration. You could also create a resource group here. And the most important thing is where does it run, and is it free or not? So in this case, it's not free. And so we created a new resource here, and come on.
It's way down at the bottom.
Hmm?
It was at the very bottom. We called it demo code.
What did you say?
It was like the last one in the list.
Oh yeah, so yeah. Anyway, so that's what I created right now, right? So, and that then has the information that you would need, this resource ID and so on in your code, right? Let's go back here. Come on. But it should. Yeah, so and then you want to create a new project, so you give it a name, code on the beach, and a description, test. And then you choose a resource group that you have somewhere, so demo code, for example, right? So, and now you need to choose between the project types. The difference between classification and object detection is classification tells you what is the whole image, and object detection tries to find things in the image and gives you the boxes around it. And then, depending on what you select, you have a bunch of other options here. You have multi-class versus multiple labels. So multi-class means, counterintuitively, it's a single tag per image. It means like I only want to distinguish cat versus dog, and don't want to distinguish. Multi-label could be dog, but it's also a golden retriever versus a Rottweiler. For example, you can assign multiple labels to an image this way. And then you have those domains. Between the general domains, they just got improved over time, but the general domain is a general purpose domain of the underlying model that the transfer learning is being used for. And then you have specialized ones for food, for landmark, and for retail, because pictures of food and pictures of landmarks and retail packaging are can use for better results that they're often similar. Retail packaging often has very clear shapes, very clear colors, and so on. And versus food has also a different color spectrum typically, and it's more round shapes and so on. And then there's another option here, the so-called compact models. I mentioned those earlier. If you choose those, then you can export those, the model that you generate to your computer later on. Yeah, so if I create this, then I could add images here, and I started wearing glasses last year, so I took pictures of myself wearing glasses. So I didn't, you notice that they show up as untagged, right? So now I could select all here and tag images, but I could have also assigned a tag while uploading it and say glasses, dude.
Would it recognize that it's you?
Yeah, so that's what I wanted to, I'm getting to that. So this is actually, what I'm training here, you only train as good as your training setup. So it will not detect if anybody wearing glasses, it detects me in my office wearing in that camera angle wearing glasses or not, basically. That's what it's good at, right? And then I can tell it to train, and I do quick training. I can assign a processing budget otherwise, so it takes longer time, and then the training runs in the background. So I will move on to a different part of it, because training could take a while. So here are a few prepared things that I have been doing before. For example, here I actually used it together with a different device, the Azure Percept device, which is an IoT device of Microsoft, and that has an integration to the service where you can even remotely tell an IoT device, take a picture every 5 seconds, upload that. In this case, I took a picture of my home security camera, and so and trained it to be able to recognize if it's looking at me or not, right? I don't have an example now for let's see, for object, let's see if I have an object detection example. Oh yeah, so here I call it auto object detection. So what I did here is I used actually behind the scenes computer vision, the service that I showed you first, told computer vision what do you see, and then I in an app counted if I see in things more than 15 times, and if I see them more than 50 times, then I would upload that and automatically tag it. Otherwise, you would do it yourself. You could make a tag here and then say this is a brooch or something like that, and assign a tag to it. And this service, then, if you would call it would give you bounding boxes for what you trained it for. Let's see for training meanwhile. Sorry. So it's still processing. Okay. So let's give it some time to train and run. And actually, I could try to log in into the projects here and see if I can change my login into, come on. No, I don't think that will work. Never mind. Let's move on. We will get back to that when the training completed. So Face API is a service that has two main components. One is gives you more detailed insight about faces, meaning landmarks in the face, and is a person smiling or not, are they wearing glasses or not, and so on. But it could also identify a person. I'm not going to show that today because I don't have now a data set of example faces and do face recognition, so you could implement your own security system with that. Caveat, if you do that, Microsoft will ask you, what are you doing? Why do you want to do that? And they currently do not allow law enforcement agencies, for example, to use that service. Yeah? So it's more meant for like a fitness studio or recognizing your customers who opt into it than to do it with people who do not opt in, right? It also can find similar faces and group faces. So, but let's look at it hands-on. First, on the website here. So what it does here is, so it does face verification. Oops, unable to find faces in the image. Huh. Okay. So what it was supposed to do is show you, like if you see that image on the right side here, that it gives you, tells you if they're similar or not, and with a confidence interval, right? So again, let's go to the sample code then of what I have available. It's funny, I tested it tonight, but okay. So as with the other ones, you initialize a client and then you set up a few parameters. So here you would need to read the documentation. There are different recognition models as over time they implemented improvements. And each of those recognition models and detection models, they're enumerated as a number here, has some advantages and disadvantages. And here, for example, the face attributes here for the detection model are only supported with detection 01 right now, 01 right now. So let's look at an example. So here's we ran it for this image here. So you see three people here, two ladies and a gentleman. And let's see what Face API gives us as a result for this. The call is, so similar to computer vision, you also tell it the things you're interested in, right? You tell, in this case, we're interested in the age approximation, gender guessing, head pose, and pretty much everything in this case, yeah? So let's detected faces. Let's see what it detected. If we look at the printout, I mean, I know it's a little bit small, so it gives you face attributes first. So attributes would be the age, 22 estimation. It's blurry, so that must have been the lady in the front then, very high. It's an emotion, so it thinks it's a neutral expression. What is the exposure settings? It's a good exposure setting. Facial hair, no beard, mustache, and sideburns for that lady. And gender female, glasses, no glasses. Hair, not bald. Hair color, I forgot what it resolves in. So red, thinks it's red. Oh, interesting. Blonde, confidence 1, quite higher even. So confidence 1 is the highest you can be in. The head pose. What is the head pose? It's basically the 3D orientation of the head. In pitch, roll, and yaw for pilots and so on. That's something you should probably know. And then it's a person wearing makeup, so yes. Occlusion, it will be able to say like if anything is occluded, so you could actually implement something like somebody entering a building needs to show their face and before you take a picture, or if you have an automated passport or ID picture taking, you could use that to pre-filter if the face is well visible, right? Let's move briefly to, just an example to look at the second person, 32, facial hair. There's it's a little bit of, it thinks it may have facial hair. And then the face landmarks, as I said, also are set up, which are given in coordinates, like pixels on the screen. So you could actually cut out the eyes of the person and automatically blur the eyes or remove the eyes, for example. So you could make pictures automatically semi-anonymous, and here is the bounding box, the rectangle of the detected face. Yeah. Now, let's see. I have a breakpoint, so it should be fine. So, and here's all the things again printed out. In the example file, here's the age, good exposure, head pose, and so on.
So it can know age also?
It tries to estimate age, yeah. I'm lucky. Usually it thinks I'm younger than I am, but let's see if we can find similar. Actually, in the sense of time, let's skip that and let's see if we have enough time at the end, we can go back to it.
What's the difference between recognition model and detection model?
The question was, what is the difference between a recognition model and detection model? Recognition model is actually then used when you would run the face recognition with that data set of 75 million, up to 75 million people that you want to recognize a person. So in this sense, it's actually not really used. Detection model is more like you want to detect the faces in the image and not recognize who it is. Recognize is like recognize Mr. Gopisetti versus Mr. Erben, and detection would be just here's my face, here's your face, and I didn't shave. So yes, those are the example images. Just a cheat sheet for me in case I would need to show what we're looking at. Azure Form Recognizer is an automated system to analyze images of forms, as I said. You need to provide 5 examples, and then it has pre-built recognitions of some specific types of forms. Now let's see if there are also error messages there, but okay. Okay, browser change. Okay, for some reason it doesn't switch between the images today, but let's focus on the one on the left side. So this is an example where it's a custom form. So that means somebody uploaded enough examples of it, and then they fed that custom form into Form Recognizer. You see it has, it's basically a list of items, and in this case an invoice for project 2. Yeah. So what it gives you is then key value pairs. Like key value pair would be phone is 432550189 and so on, right? And gives you a table, and the table has then all the different fields you can have in the table. I mean, it's the way it's structured is, again, it's a big JSON. So again, you get here bounding boxes, text, build to, bounding, and the bounding box that is relevant to it. Geez, I mean, something is a little bit iffy right now. Okay. So basically it gives you the JSON that with all the different things in the form, including recognizing tables with the respective bounding boxes and the content that's in that bounding box. So for some specific models that have been predetermined, you get a little bit more structured output. For example, for receipt, if it would work right now, you would get the the total, the sales tax, and all those different things that may be on a receipt. There's support for ID for passport and driver's license, US driver's license, and international passports, where you also can get the typical data that you have in a passport, the expiration, the passport number, and so on, by just telling the form recognizer, hey, please recognize pictures of passports. Yeah, there's a question?
Does it recognize if the form's skewed or upside down and try to correct it?
I don't think you get the metadata for it. I haven't tried that, to be honest. I mean, it's meant to be relatively robust, so he would be an example if the website would load that's a little bit crumbled receipt. But in general, you should provide it as good as possible. Let me put it this way. So
go through something else to straighten it out first. And then
yeah. So
Can you train it to recognize dimensions? So so it can see how big a box is or something to that effect?
The question was, would it recognize dimensions? I mean, it would give you the bounding boxes, or what do you mean with dimensions? It's a form.
I guess it could calculate how big something is depending on the bounding box. That makes sense.
I mean, it's meant to recognize forms like receipts and
Right.
and so on.
I was wondering if you could train it, like if you tell it that this box is 1 inch by 1 inch. If it's
Yeah, you wouldn't need to assume that you know the size of, I mean, because I mean, if I take a picture from here and from there, it would have no way of knowing that. So, I mean, you would have to calculate from the relative dimensions to whatever unit of measure you use.
How does it do in handwriting?
It's doing it, but so it's also very. How well? I don't know, to be honest. They're improving it every few months, and they're adding features. For example, support for different languages. Initially, it only did English, and now it can support a lot of other languages and different text directions and so on. But you typically need to tell it what language it is in. So, a question over there?
To follow up on that, how's it doing with bad handwriting, such as engineers or doctors?
Okay. How does it do with bad handwriting? Try it out. I mean, I'm sorry, I don't have a good answer for that. Yeah. Yeah. So, I mean, when it first came out, it really only worked with PDFs and so on, and then they improved it over time. But it's something that's a higher level service that they have been improving on for quite a bit. So, but I want to move on to the next service so we can cover that also. Azure Video Analyzer, finally, I mean, is extracting insight from video and audio files via, or now indexer via machine learning algorithms. It's basically combining a lot of the cognitive services into one. It's built on top of Azure Media Services, cognitive services, and Azure Search, and has a REST API and also a platform. Platform would mean it's a website you can upload videos onto, search, and look at the results, right? So this is an older picture about the whole pipeline it does. Like it can do audio analysis and video analysis, and both start with transcoding. And then, for example, in audio analysis, it does things like language identification, voice activity detection, speaker diarization, sentiment analysis, not based on the tone of the voice, but on the words used, and detect brands. Brands are, I mean, they put it in audio, but it also finds brands that are mentioned in images found. Let's say you have a picture of Microsoft, then you would see the brand highlighted as the brand was used in that video. On the video side, it uses, and you can guess, uses Face API also. It does face detection, groups faces, can find the best face, and can also identify faces. So it can also recognize VIPs, and you can also provide it, you can hook up your own pre-trained face API to recognize people that you know in specific videos. But this is all very abstract, so I will just show it to you in a second. And that's just an overview of the feature set. I mean, yeah, so have a look at. It's a lot of things, and it was really meant initially for media companies who have a lot of video and want to find their video easily, right? But let's have a look. I think I opened the page earlier already, videoindexer.ai. When you log in first, you see videos that you can also upload a video, let's say, browse a file. Come on. Here are my videos here. And let's say, uploading this one. And then it uploads it in the background and will start processing it. So how does it processing? You would need to initialize on the Azure side of the game resources, Azure Media Services resources, and you assign processing capacity to it. So reserved units, and the more you assign, the more running cost you have. You can also run it with on demand, but then it will index really, really slowly. So you see that it starts to index, and now it is 5%, right? But let's look at something that already has been done. This is an official Microsoft video. It's basically an advertising or a video about Azure Stack. Azure Stack is the service or the product where you can basically take Azure in a box and run it on your own premises, or in this case, in the back of your truck, right? You see the video has subtitles. You saw the brand Microsoft in the video, and has all sorts of things, right? So you could get all the insights in the video by just saying download, and then you get the JSON, and the JSON is the thing you would also get when you call that service from your APIs. You see it's a really, really, really long document with a bunch of start times and end times and things that happen. For example, here it says the mountain. It found a mountain and it appeared in the video with this confidence here, at that start time until that end time, and so on. So fortunately, the portal also gives you a little bit of richer experience. In this case, it actually got a little bit confused. It thinks there are 6 different people in the video, but there's only 1 person in the video. Yeah. So yeah, that's the power of AI. It tries to make sense of what it sees, and it's usually meant to find different people, and so it may get confused if there's only 1 person. So it also tries to assign topics based on what has been discussed in that video. In this case, robotics. Well, there's a drone in there. There's artificial intelligence mentioned. But interestingly enough, it also talks about surveillance state. Surveillance state, yeah, because it mentioned monitoring in the text, right? So takes those the topics. The further you go down, you go with a little bit of caution. Yeah. So and then you can jump in the video to things where the topic would have been found. Yeah. Keywords. Again, it also has keywords. For example, here, people are mentioned. Power. Yeah, it's actually power line. Yeah. Let's see. Amazing. Yeah. So he talks about how amazing it is. But there are also labels. Labels are, for a lot of people, more meaningful. When I go to tire, for example, I should see a tire of a car in this case, see? Or here. And named entities, here's a brand, Microsoft. Microsoft brand was found here because he talks about it. And also, I think here because it's visual as a text, right? There's a few places where it didn't recognize the brand Microsoft. For example, it didn't detect the logo. And in this case, what we actually did is, and we're running out of time, this is where we found an opportunity to increase it, and we basically implemented a custom Microsoft logo detection on top of, and added that to Azure Media Services in our own application. So we analyzed every frame, and then we were able to find also the logo. Why would you do that? For example, let's say your TV station, you want to sell advertising space. It would be nice if the logo was also, the brand was also present in the video at that timestamp, right? Okay. So briefly, very briefly, let's see if the training of custom vision meanwhile completed. Did I have it? Yeah, so it will complete it, and it gives me basically performance characteristics of how well it's able to recognize things. So, and let's do a quick test. And you have APIs for all of things also, so you should be able to now upload a local file. So when you do a test, it's always important that you do a custom vision, that you test it with something you didn't use for training, because otherwise you overcorrect. And this dude here is wearing glasses with 75% probability. That's a quick question.
How would you expect them to do if you took a picture with your laptop camera?
Okay, let's try that quickly. Camera app. And now, where do they actually show up? Do you know where the pictures show up that you take? Camera roll, right? Geez, Jiminy Crickets. Let's try it quickly. From
Probably do go file save as camera.
does it have file save? It should. Yeah, that's let's see if it. Ah, God, I'm starting to fumble around.
Sort by date time.
Huh?
Sort by date to-do list.
Yeah, but you need to. Okay, here, right? And there's things, see, it's confused. So, yeah, so that's what I'm saying. Like it may be confused because, for example, here there's the lights are not on. It's just a different environment. So it's this old thing. Like if you train to detect roses versus tulips, and you have the roses indoors and the tulips outdoors, you may actually have trained inside versus outside behind the scenes. You cannot know for sure. There's another question.
Yeah, we saw that the Azure site wasn't working perfectly. Do the services go down quite often?
I haven't seen this happen yet, so to be honest, I don't know what's going on there. But
Or it's the images are more than 4 MB or something?
yeah, but I mean, those were examples by Microsoft, not by me. So, yeah. So, in the sense of time, one last question there.
I was just going to ask, like, how does it compare? Like, what competitors does it have, and like, who are they competing against, and how do they compare?
So, I mean, obviously Google is always competing in everything, but Microsoft was first with those services before Google. So, yeah. So, I didn't do a performance shootout yet. Where Microsoft is really strong at, especially in custom vision, is to specialize it for subject domains, like for retail and so on. So that's where I would see it. But thank you. We need to wrap it up, unfortunately, and thank you for your attention. I hope you got something out of it.